Welcome, everybody in the lecture hall. Welcome, everybody on Zoom. Welcome, everybody watching us from the future. Today, we are going to start a new topic, new week, new topic, and we are going to focus on the vocabulary, the terms, and in particular, the preparation of the collection prior to indexing. So we'd see, and the points that I will try to make today is that it's complicated, much more than you think. I oversimplified last week. So what we have seen so far is this structure, which is known as, does anybody remember? The standard inverted index. Exactly, that's the standard inverted index. Index because it makes it faster to retrieve the documents in a collection. Inverted because instead of listing the terms that are in a document, we do the opposite. We list the documents to which the terms belong. And standard because that's going to be the basis for many modifications that we are going to do in the rest of the course. So standard inverted index. We looked for our first prototype into a specific kind of query language based on Booleans. So you input a few words and you separate them with and or not. Gives us a very simple query language. And what that gets us is an output that is a set of documents. So it's a subset of the collection. There is no particular order. There is no ranking. There is no ordering. These kind of systems, I think the first ones probably appeared in the 60s, 70s, became very popular, for example, in legal offices with lawyers, to search, full text search of legal documents. It was an art in itself, just like writing a prompt for an AI today, writing a query in order to find the documents that you are looking for required a lot of skills that people back then were trained on. So we had this simple EBNF, right? That's the simple grammar for a very simple language. And you have the exercise that I think starts this week that you're supposed to write some Python codes to make it all nicely work. So the model that we took is that instead of looking at the document as a list of words, like we all normally do when we read a book, we look at it as a set of words. That means we forgot the order in which the words are, and we forgot also the number of times that the words appear in the document. So that gives us a representation of the documents as a vector of Booleans. And I posted a few fancy things for those of you who are a bit bored and want to take it further. So the structure is called technically a module over the semi-ring of Booleans. But you don't need to understand that. We just take a vector and fill in with zeros and ones. That's basically what we need to know for what we are doing here. And so we tried to abstract from this last week, and we saw that, in fact, what we get when we look at this list as sets is that we get a term document bipartite graph. It means we have the documents on one side, the terms on the other side, and then we have links between the terms and the document. Either they are connected or not, and that's the Booleans we get in the vectors. So we saw that we can use adjacency matrices as the representation. We saw it's a huge waste of space because there's going to be zeros all over the place. So that's not the way to go. And instead, we moved on to the standard inverted index with the idea of postings. A posting, remember, is a pair, a term document pair. But since all the postings with the same term are on the same line, we don't repeat the term in every one of them. So that's why in the posting, we just write the document ID, but the term is on the left, and that's shared by all postings. So if you want to compare the visuals, the documents in the bipartite graph would be these on the left, right? In the bipartite graph, you have two kinds of nodes, so the documents are here. In the adjacency matrix, it's a columns. And then in the standard inverted index, it's the set of all postings that have the same document ID, right? So all of these are the same documents. Then we have the terms. So in the bipartite graphs, these are the ones on the right. In the adjacency matrix, these are the rows. And in the postings, this is a specific term and its postings list, right? And then finally, a posting is a pair term document. So in the graph, that would be an edge, basically, between a document and a term. In the adjacency matrix, that would be any one in there, any place where there's a one. And then in the standard inverted index, that would be a very specific posting, right, for a specific term and a specific document ID. Who is with me on this? By now, it should be all clear, right? That's what we did last week. And so since you understood everything that I told you last week, you should be able to answer the following two questions. And I hope quite quickly. What documents does the query A and B return based on this standard inverted index? Now, it's no longer a matrix, it's a standard inverted index. So there's four possibilities, A and B. Let's see if some majority emerges. Yes, we do have an emerging majority. So the question, I guess, was intersection or union? Anybody? Intersection or union? Intersection, exactly. So the intersection, you remember this nice algorithm in linear time where you walk down the lists at the same time and you realize there's 3 that is here and here, and 8 that is here and here. So this is indeed 3 8s. Okay? And I think the other answer, the first one would have been a union, but that would be or, that wouldn't be and, right? Which brings us to the second question. What documents does the query C or D return? C or D? Did I start it? Yes. And we get 100%, almost 97%. All of them except 6. And you can see C or D, we have 1, 2, 3, 4, 5, 6, doesn't appear in any of them, right? So this is why we don't have 6 here, then 5, then 7, 8, 9, right? So this is the union. And also here, we have a linear time algorithm that jointly walks down the two lists and outputs the union. Okay. Now I'm going to move back to the slides. And again, normally, I should land right where we stopped. Yes, we did. Okay. So last time, I oversimplified things. I just gave you a collection, then we just tokenized it with the spaces, and then we got this standard inverted index. It was pretty quick to do. I did it on a small example, but the thing is I oversimplified. And what I oversimplified, we'll cover today, is that we need to collect the documents. So first we need to decide what is a document. Then we need to tokenize. That's absolutely not trivial, as we will see. Then there is linguistic preprocessing, even less trivial, especially with all the languages that there are in the world that all work in different ways. Finally, we need to build the index. So building the index, that can also be complex for scaling, but we'll have weeks dedicated to this. Okay, so the documents. Let's focus a little bit on this preparation. So we want to collect documents, millions, billions of documents that are going to be the nodes in our graph, or that are going to be giving us the document IDs in the postings lists. So the first challenge we have is that we need to read the documents, decode it. And that's where it starts, because a document is basically a sequence of characters, but the sequence of characters, you know that they are encoded in bits, right? Zeros and ones. So you all know the ASCII encoding, that was one of the very early ones. But of course, this works because it's English, right? And so you need to know which encoding to use. There's ASCII, there's many other encodings. which is why I have a question for you just to check how far you go in your knowledge. And my question is, which one of the following is not an encoding? Unicode, ASCII, UTF-8, macOS Roman. One of these is not an encoding. Aha. It turns out that macOS Roman is an encoding, and it is Unicode that is not an encoding. Unicode is a standard that is just a catalog of characters that are indexed. There's character number 1, character number 2, and it goes on and on and on and on with probably millions of them by now. And regularly, there's a standardization body that meets and that adds new characters. I think by now they pretty much covered most of the alphabets we have on the planet, and the new versions are pretty much new emojis, and so that's keeps getting updated. So Unicode is not an encoding. It is only a catalog of characters. In fact, the name of the encoding, or one of them, would be UTF-8. UTF-8 is an encoding that is based on Unicode, so it uses Unicode in order to encode. I will show you. I have a slide on that. There's also UTF-16, UTF-32. So if I just tell you a document is encoded in Unicode, that doesn't help you. You don't know, is it UTF-8, UTF-16, UTF-32? You don't know, right? Unicode, just a catalog of characters. ASCII is an encoding for English, a very early one. macOS Roman, that also is one that was used on Macs before. By now, whenever you build a new application or create a new startup or a new company, just go for UTF-8 immediately. Don't even start with anything else, because once you internationalize and grow, you will anyway have to do it. So it should be almost something automatic to start right away with UTF-8. Okay. That should be this one now. All right. So ASCII looks like this. You're computer scientists, you've seen it probably so many times, and you know that it's all about mapping, for example, this character P to 50, and 50 in base 16 becomes this in base 2, right? All right. So UTF-8, who is already familiar with UTF-8? Some of you, right? So the idea is that it's elastic. It's the size of the bit sequence that you get for a character depends on how complex it is. If it's one of the very early characters, especially English and so on, actually, in fact, ASCII, pretty much, the first half of ASCII, if it's at most 7 bits, then you just go ahead and encode it with a 0 and then the 7 bits. In fact, it turns out that it exactly coincides with ASCII. If you only have characters that are in the first 127, then it exactly matches with ASCII. So that's why when you open a document, even ASCII or UTF-8, you will see the same thing. But the problem starts when there are special characters and you still try to open it in ASCII when it's in fact UTF-8. This is why you see all the strange symbols appear, because then it's not using the proper decoding. And that happens typically when you have letters that are in the Unicode catalog much further down. So the number in the catalog would require in base 2 8 to 11 bits. Let's say that's the case of the letter pi, Greek letter. And this you do with 2 packets, a first packet starting with 110, and a second packet starting with 10, and then you squeeze in the rest of the packets these 11 bits, right? 5 on the first packet and 6 on the second packet. And the 110 tells you that's the first of 2 packets, and the 10 tells you it's a continuation packet, right? And then the same goes if you have even more symbols. So the euro is an example of that because it appeared much more recently, and this one is in the category 12 to 16 bits, and in that case you need 3 packets. The first one starts with 1110, tells you it's the first of 3 packets, and then 10 and 10 for continuation packets, right? And then you squeeze up to 16 bits. And then it probably goes on and on if you have even above 16 bits, right? UTF-16 is similar, except that it encodes in packets of 16, and UTF-32 just does packets of 32. So in fact, it's probably not even elastic because we probably don't have yet enough characters to fill in the full 32-bit space. All right, but last time somebody said that 640K is enough for the entire family for the working memory. That wasn't proven true, right? So you never know. All right, so that's UTF-8. And of course, the first challenge when you decode the collection is to find out the encoding. And that in itself is not easy. Sometimes you know, so when you know, that's good, somebody tells you. Sometimes it's going to be annotated in the document. Maybe the first bytes of the document can tell you, maybe there's even a conflict that they don't even tell you the same thing. Machine learning by now is probably a good option also to figure it out. So that's the first challenge. You need to figure it out because otherwise you run into issues. And I'm pretty sure it happened to all of you that you tried to open a file and there were strange symbols, or you open a CSV file in a spreadsheet software and then the accent, the umlaut, EU are just shown. To whom did it happen? All of you, right? Exactly. So it's not easy. Then you have the encoding problem. It might not even be text. If you have formats like PDF, Word now would be XML, PDFs probably now binary formats. You also have, if you use some syntax like XML, these data-specific encoding, like the ampersands, lower than, and so on, are encoded in this weird way in XML. So that also you need to figure out, because if you build an information retrieval system, you don't care it was XML. You just want to know what characters it was in there. And here you should know it's an ampersand, and then it's a smaller than symbol, LT, lower than. Okay? And then, of course, the binary encoding is even more problematic because you need to know how to decode it. All right, so all of that means that we need to do a lot of work of classification in order to figure out the language, the encoding, and the type of document, and then we can start reading it. And again, machine learning can be very useful for that. The second challenge is, what is a document? Because the document might be so large that it doesn't make sense. Imagine you look at your entire email archive as a single zipped document. Probably you don't want to treat it as one document. You want to treat every email as a document on its own, right? So then it means that you need to fine-grain it and split this big file into smaller chunks that give you the documents. So think of an email archive. The opposite is true. If you're writing your bachelor thesis or master thesis or PhD thesis in LaTeX and you're having a different file for every chapter of your thesis, and then you have a main document that merges them into a single document, then you have exactly the inverse problem. Meaning you have multiple documents, but actually they are the same. They belong to the same. So in that case, you do want to index them together as a single big bachelor thesis report, right? So that's not easy to figure out what is a document. If you're a library and you have books on the shelves, of course, it's easy. But now we are beyond that. There's more than just books that we want to index, especially on the internet. So that's for the documents, right? How do we read the documents and decide what a document is in order to start reading the stuff that there is in there? What do we get from that? Text, letters. So we are not done yet. We still have some work to do because now we need to build the vocabulary. Remember, what is the vocabulary? It's the set of all terms. It's the set of all the rows of your standard inverted index, right? All the terms that appear on the left. That's called the vocabulary, just a set. Dictionary is the vocabulary plus an extra structure to look up the terms that we'll cover next week, right? But you probably already guess what kind of structure. So the vocabulary is just a set of terms. So I gave you this example last time. You probably remember that comes from Shakespeare, if I'm correct. And let's now look at it a bit more in depth. So we could say, okay, we actually did that last week. Let's throw away the punctuation, right? We might decide that it's irrelevant. Now, of course, you could start to argue, what if it's Java code? And the points are actually important because this is for navigation and method calls, right? So already there, you see, that can be problematic. But if it's just text, we can throw away punctuation. But even without Java, even without a programming language, here are plenty of examples of why it's not so easy. Because a point could be part of an email. And the email, obviously, you don't want to throw away the dots in there because you want to preserve it, right? The same for the ampersand. Then you have special characters, could be considered punctuation, in apostrophes, especially in English. Isn't, right? That's a single word. You don't want to cut it in two with isn't and t. That doesn't make any sense. You want the isn't, right? You might have apostrophes in the family names, for example. You also don't want to make it two tokens. Then you have the dashes in English, and dashes in English, what makes it difficult is that there is no rule. There is nothing that forces you to have the dash or not the dash. It's basically based on how easy it is to read. If your sentence gets too complicated, adding the dashes makes it easier to read for the reader. So the learn it all by heart methodology, for example. And here, what do you do with that? Maybe you still want to index learn it all by heart and separate them in that case, right? Then that's a related problem. In English, unlike German, we don't paste the words together when we assemble them, right? Like Vorlesungsverzeichnis, that's a single word in German. But in English, we don't do that. We just put spaces in between, like website. And yet, something happens in English is that over very long periods, it behaves like German. Because websites now, plenty of people just write website in a single word. Keyboard, it's a single word now. Keyboard, keyboard. Doormat, also a single word. So you see, it's exactly like German, but it just needs a bit of time so that the words get pasted together. Database is another example of a word that got pasted together, right? Then you have proper names like Canton Basel-Stadt. That's the same entity, right? So do you still want to treat these as three tokens, or do you want to still preserve the concept of this political entity, right? So again, you got the message today. It's complicated. That's the one message that I want to convey to you. And I threw even more corner cases like Hewlett-Packard, that's a brand. State of the art is another example. Co-education. So if you look at all the 19th century novels like Oscar Wilde and so on, you will see that today is written with a dash, dash day, tomorrow. Here you have another example of dashes to help reading, the hold him back and drag him away maneuver. Database, one or two words, San Francisco, that's an example of like Canton Basel-Stadt. Now, Los Angeles-based company, what do you do with that? The dash is basically connecting Angeles with based, and then Los that belongs with Angeles doesn't have any dash in there, right? So it's not so easy. And then cheap San Francisco, Los Angeles, now you're connecting Francisco with Los. So how do you figure out that it's San Francisco together and then Los Angeles? All right, and York, probably the new line was not correct here, York University versus New York University, right? It's the new that goes with York. All right. Then there's the phone numbers together with email addresses, the same category, the dates. And for the dates, you don't even know if it's the month first or the month second, makes it even more complicated. So yes, and then March and so on. The dates and the times are just very, very difficult. There are standards for the data representation. I think it's ISO 8601 that tells you how to represent dates. In the real world, nobody respects that. So basically, have to deal with all of that. All right, so that's the punctuation. But there is more. Because now, if you look at specific languages, so I'm going to do a tour of some languages. So let's start with English. In that case, would like a coffee, you would like a coffee, it's all the same conjugation, right? That's actually why English is so easy to learn, because the conjugation is pretty simple. except for the third person in the present, right? Then you have the S. And here you want to consider that once or want is kind of the same thing, right? It's just a conjugation. But the problem when you tokenize and when you index, if you don't pay attention and you just treat them separately, then you're going to index want on its own line in the standard inverted index, and want, so want and wants will be two separate lines, right? And maybe you didn't want that, because if the people are searching full text, they probably don't care if it's a third or second person, right? So that's an example. But then, of course, if you go to other languages, it's even more complicated. Are there any Swiss Romand or French? No Swiss Romand, no French speakers? Okay, some of you. So in French, so first, the thing with French is that mapping the written form to the spoken form is very difficult. German, it's a bijection, right? But in French, it's not. And so you have all the conjugations here that modify the verb voudrait, 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 voudrions, voudriez, voudrait. That's again all the same. It's just to want. It's the same thing as in English before, right? And so here it's even more complicated, because if you don't do anything on that, you're going to end up with 6 different entries in your standard inverted index. So not only makes it more complicated, but it's going to even increase the size of the vocabulary, right, in terms of space. Any Italians? Testicino? Ah, bueno. Vorrei un caffè, vorresti un caffè. So the difference here is there's no subject. When Italian people speak, they don't put the subject. They just directly use the verb. So that also makes it more difficult to index on the subject. So here you could basically index to refer to the person you're speaking about. But here, the information, whether it's me or you or somebody else, is basically hidden in the way that it ends here, right? So you basically have to look inside the verb in order to figure out who it is you're talking about, right? Let's continue with languages. German speakers. Okay, most of you, right? So German is, except for the fact that it's a bijection between speaking and writing, and I'll come back to that, what it means for indexing, for spell checking next week. It's like French or Italian, right? So here we have all the forms for the conjugation. Even though there's more like möchten, möchten, it's twice the same thing. Möchte, möchte is also twice the same thing. So it's kind of in between, let's say, French and English. Okay. Then I told you about German that you can paste the words together. That was back then, I don't know if it's still the case, but the world record in German, the longest word, Donaudampfschifffahrtselektrizitätenhauptbetriebswerk Bau-Unterbeamtengesellschaft. It means the association of the subordinate employees of the of some society that controls the electric boats in the Donau, which is Danube in French. I don't know in English, but basically that's very, very long word. How do you tokenize that without any knowledge? Where do you know how to put the limits between the words? So again, it's complicated. Then when you want to understand and go into grammar, you have even more issues, for example, with the Swiss German dialect. Who speaks Swiss German? Der Schweizerdeutsch? Really? So you know that there's differences between German. It resembles it, but there's things like we don't have any past, preteritum doesn't exist in Swiss German. You say ich bixi, nicht ich war. And then there's a few words that change in the order in the sentence. Ich habe gedacht, du hättest einen Kaffee trinken wollen. But in Swiss German, you swap them. Ich hatte gedacht, du hättest einen Kaffee werde trinken. So you have these swaps all over the place in the way you put the words. And something else that I don't know if you have noticed is that in the subordinate clauses in High German, the verb goes at the end. But in spoken Swiss German, the verb in a subordinate clause is often put at the third position. So you basically don't put at the second one to not confuse with an indicative tense. You put it at the third position to make clear it's a subordinate, and then you still continue to add some words after that. And then there's also combination like trinken zu wollen, vellet trinkre. You put the Z in the middle. So yes, that's also not easy. And I think Swiss German even has features that were very interesting for context-free grammars. I think it has some. There's a lot of nice examples of exceptions that break rules in Swiss German compared to a programming language that is related to this. Swedish people? Very good. So we have from everywhere. So jag skulle vilja ha en kaffe. That means I would like to have a coffee. What I love about Swedish is that you don't even conjugate anything. It's just literally the same everywhere, always. There's not even an S in the third person. Now there's a few pronunciation things. For example, the DE at the end, so the third person plural is pronounced dom, right? You say dom, skulle vilja ha en kaffe. And it's not written in the same way. So it's not completely bijective here. All right, I really like Swedish. It's basically a language that has the German words or words that resemble German with the simplicity of English and with the grammar of French somehow. And so it's a very nice combination. And it sounds good also. Mandarin? Yes. So this is an excerpt from I think the Wikipedia page. It explains to you that China is a country in Asia and so on that has 23. You see the Indo-Arabic characters, 23 provinces and so on, right? I think that this one, if I'm correct, I was told by native speakers, it mixes the simplified alphabet with the more elaborate one. So it's a mix of the two, which normally you don't do. So yes, and so the particularity here is that unlike in English, where you have 26 letters in the alphabet, also German, French, and so on, or Swedish, here you have thousands of characters. And so that makes it also very complex to index, right? And for learning also, it's not easy. I mean, I'm trying to learn, but I focus on pinyin because I have a very hard time mapping the characters and remembering how each character is actually pronounced. All right. क्या को हिंदी बोल सकता है? No Hindi speakers today? Let me explain, because here it's also very interesting, the Hindi language. So here, that also means the same. I would like a coffee. But the way they do it is that the would like is actually here. It's basically this chahe thing. And here, that actually is like the dative in German. Muche is to me, mir. Tumko, that means to you, so dir. Use means to him or to her. It's the same word for he or she in the pronoun here. But there is a difference whether the person is next to you or far away. Use is you say that somebody would like a coffee who's far away from you, and ise a café chahier would be a person that is close to you. Right? So they make a difference between the two. And then you have hame, that's we, apko, that's also used as the formal address. There are three ways to address people in Hindi. So in German, it's du and sie. But in Hindi, there's tum and ap. So there's three different levels. And here again, for the third person plural, that's unhe. And there's also inhe for the persons close to you and unhe for the persons far away. But what's interesting is that even though the pronouns are the same, male or female, when you conjugate, you make a difference, male or female. So here, it's me's term acha parahahun. I will study well this semester. Raha is male, rahi is female. So you here change the gender in the conjugation of the verb, right? And here, so that's another example of dative. Muche information retrieval by hood passant here. I like information retrieval, and that would be the third person, the first person conjugation. And you see, it's almost a single characters. In fact, it's two characters pasted together. It's a consonant and a vowel pasted together. So you see the complexity of that when you actually have to parse this. In the Unicode, I think it's still two characters, but there is a special characters in the middle that pastes them together. But you have to take care of all of that when you actually parse. In Hindi, you also have future tense and so on conjugated just like French or Italian, right? So parunga means I will study, and you also make a difference. Parungi means I will study, but as a female speaker, right? This is really a nice language. The alphabet, it's not like a Chinese where you have thousands of characters. In Hindi, you maybe have 50 characters roughly. I don't know the exact number. So a bit more than in English, but it's still an alphabet that is used in a similar way to European languages. That's why we say Indo-European languages, by the way. All right? So that was Hindi. Now, still have time for the break. Do we have any Siberian Yupik speakers? High in the north. I actually needed some time to find that. I found a paper that studied it a little bit. So here we have Nekyak Tukyu Gumayak Petalu. That's a full sentence. So here, the entire sentence is just a single word. It's not just a compound word like in German, like this Donau Dam Schifart. It's the entire sentence. So if you look at it, Neg means eat. Yaktug means to go to. Yug means want. Uma is the past, something happening in the past. Yag expresses frustration. Pet means if inferential evidential, it means it turns out that. And A is the third person, and Lu is also. And so if you paste that all together, it means also it turns out that he or she wanted to go eat it, but is the frustration component, right? So that is yet another language. I don't know if there's a lot on this one, but the fact that the entire sentence is a single word, in order to tokenize this, it's going to be even harder. But I will show you in the second hour that LLMs kind of solve that with the tokenization, but I'll come back to that. By the way, another language that interestingly pastes words together is Turkish. In Turkish, you also, when you conjugate the verbs, you also assemble several components together. What is interesting about Turkish too is that the words combine the vowels in a restrictive way, in the sense that you have A, O, U, E in the same word, or U, E, E, like also in the same word, but you do not mix the vowels from these two families. So either a word is going to have only vowels from the first group, or it's going to have only vowels from the second group. All right. So I'm done with the language, but you got the message, right? It's complicated. It's very complicated because of the diversity and complexity of the languages in the world. So assuming we have solved that, figured it out, and we are able to infer the tokens and the terms, I would like to give you a bit of terminology. And here, don't worry if you have a headache, because it's not easy at first, but there are 6 different things that are related that I would like to give you names for. And I'll go through these 6, then I'll have a summary table. So when you have just tokenized the documents, and you still see the documents in there, and you still see the order and where the tokens are, this is called a positional token. So this hour here is a positional token. It means that positional because we know where it is, token because it hasn't been processed yet, so it's just still as it appears in the text, and we see it in the context of the documents. Now we have the notion of non-positional token, which is the same thing except that we forgot the position. We still know that it's in the blue document, it's in document 3, but we don't know where. That is called a non-positional token, right? Everybody with me? So the third one is a non-normalized type. It means we forgot the document. We just know it's our, that's a word. It's non-normalized because it hasn't been processed, it's still as it appeared, but we don't know what document it is or where it is in that document. Non-normalized type. That is another non-normalized type, is. But now, if you remember what I told you about the languages and the conjugation and all the different forms of the verbs, you might want to normalize this, to say is the conjugation of to be, and so we replace it with be. Now we have a normalized type. And whether it is or am or are, and so on, then it's the same type, and you call it a normalized type. Now, when you have these normalized types in the context of a document and at a specific position, you call them positional postings. It means that be, the verb to be, is appearing at position 3 in the blue documents. But it's the type look at, it's the processed term. You don't look at the original, which was is, right? It used to be is. But since now you're looking after the processing, it's a positional posting. That will be the small number that appears in the standard inverted index. And you see these are the same normalized type, B and B, but two different positional postings. And the sixth one, you probably guess, non-positional postings. So you know that here it's in the blue documents, but we don't know where. And here, B is in the red documents, but we don't know where. It's the non-positional postings. So if it's too much, I have this summary for you of the 6 things that I've been telling you, and it's really just organized along these dimensions. It's raw or processed. Raw means we just look at the original symbols in the document without any linguistic post-processing of the sense I told you with the languages, or it is processed. And independently of that, there is a second dimension where we might look at this raw or processed thing tied with a position, meaning it is in that document at that position, or tied without position, meaning that we just know it is in that document, but we don't care where, or not tied at all, right? And the same here with processed. And you see, tied with position row, it's positional token, tied without position, non-positional token, not tied row, it's a non-normalized type. I also say words a lot. Processed tied with position, it's a positional posting. So here you see you're close to the index now, this standard inverted index. Positional posting, non-positional posting, and not tied, it's a normalized type, or we also call it a term when it is in the index. The problem, and this is why I get all of these headaches, is that when people speak casually, they just are not so precise. And for example, you might say posting, just posting without specifying what you're talking about. Until now, when I talked about the posting in the standard inverted index, I meant these non-positional posting, because it's just a document and a term. So this is in that sense. But we'll see either today or next week that we can also have indexes with positional postings that remember the position of the words. And then the same goes with type in the book. If you read the book, when they say type, they implicitly mean a non-normalized type, right? And if they mean a normalized type, they would say it explicitly, right? And then token can be ambiguous. A token can be the physical token, like right where it is. But for example, if you write a compiler and you have the tokens in your lexer, then these are just what goes into the parser, right? So it's not specifically in any documents, like let's say for or while or if, then, else, these are just tokens. And so again, that depends on the context. So yes, it's complicated. There's all this terminology. What I want you is just to be aware of it and to be aware of the 2 dimensions, right? Always ask yourself, whenever you read in the book and we are talking about some terms or words of postings, always ask yourself, am I talking about something that is raw or that has been processed? Am I talking about something outside of any document, or inside of a specific document, or inside of a specific document and at a specific position? And once you understand that that gives you 6 different things, it helps with the understanding, even when people are too casual, because at least it makes you think, like, what did they mean here? Which kind did they mean? Okay, so who is with me? Right, very good. And I will try to be as precise as possible. Maybe sometimes I might not pay attention or make a mistake, but when I use the words like dictionary, vocabulary, document, term posting, positional posting, I will try to be careful to really be consistent with the words as much as I can, right? And then the more we will look at it, the more familiar it will get, and then at some point you will get the points. So I think that was enough for an hour. I think everybody deserved a break, and we will be back in 15 minutes at 11:15 for the second hour. Thank you very much.